I'm going to do a quick video just to show you this one type of problem on Delta Math because it's definitely one that really gets you thinking and can take a while, as simple as it's presented. So they give you three functions, and your job is to figure out which one is the original, which one's the derivative, and which one's the second derivative. So when you're going through here, one of the things that I like to look at is I like to look at where it crosses the x-axis, because essentially, if you have a derivative graph crossing the x-axis somewhere, it should be an extrema on the original. So I kind of go with that first. So like, for example, this one only crosses the x-axis at 2. So that would mean the original would only have one extrema. So potentially you could have something going on here. If you look at this second picture, we have a graph crossing at -4 and at 6. So we're looking at a place where we could have extrema there. Now, if you look down here, you actually do have an extrema right around -4, and you do have an extrema right around 6. So then I'm going to start looking at signs. It's above the x-axis, so that it goes above to below, which means if this was the derivative, it would be increasing and then decreasing, creating a maximum, which does happen here. And then this one is below to above, so negative to positive, decrease and increasing would be a minimum. So then you can start looking at things like, what about the extrema on this graph? So the extrema on this graph, if this was the derivative, is 2, which means the second derivative would have to be 0 there. And then you can kind of see that's what's happening here. So again, it takes a while and it's so easy to work yourself into a puzzle, but you want to start looking at things like that. When are certain ones 0? When do they have extrema? What ends up happening with this one is this is the derivative graph. This is the original function. So this one goes increasing until we get to here, decreasing all the way to here, and then increasing. Also notice your concavity only switches once. It's definitely concave down in the beginning, which means my second derivative should be below the x-axis. And then somewhere around here, it switches concavity to concave up, and that's what's happening in this picture, which ends up being the second derivative. I am definitely in no means saying that these are easy, but it definitely shows you kind of what you're looking at here. And that's what they're doing here. They're looking at when's this positive, and matching it up with increasing and increasing. So they kind of did the same thing that I did with that one. This one, same idea. They're giving you all these pictures and trying to figure out what's the original, what's the derivative, what's the second derivative. So I haven't looked at this one yet, so we'll kind of authentically talk about it together. So let's see. We have this one is increasing, well, maybe kind of decreasing for a second, increasing all the way until it gets to around 2, a little before 2, and then decreasing after. This one is decreasing until around -3, and then increasing to 6. Well, that could be here. So let's see here. If we are decreasing until -3 and then increasing, so we would have a negative derivative and then a positive derivative. So that does happen here. Negative derivative, positive derivative. And then we are increasing to decreasing, so positive derivative, negative. So this could be the original. This could be the derivative. Let's see if our concavity matches. So if this is my original, it's concave up and then concave down, which means it should be above the axis and then below the axis. And it should switch concavity somewhere around here before 2, which again looks possible. Let's see. What else do I want to check? This one, if this is my derivative, it has a maximum at just before 2, which means that should be when the original, when the second derivative crosses the axis. I'm going to go with this. Let's see if it lets me submit it. There we go. So they did also very similar, increasing, positive. Seems like that's the best way to go with that one. So I just want to show you a couple of those because you can start kind of running yourself into circles if you don't take your time and try different things. And it's definitely something that can take a little while to get a hang of.